in this series. And today's lecture is about Jupiter. And this lecture is will be delivered by Dr. Guruprasad, who is the director of this Jawaharlal Nehru Planetarium. Before the talk, I would like to introduce the speaker. Dr. Guruprasad is the director of this planetarium. Before this, he has served as a satellite scientist in satellite mission planning and later heading the media and public relations wing of ISRO. Apart from all this, for more than 2 decades, he has been very active in science communication, which is his passion. He has authored 13 books, among which some have been translated to various Indian languages and contributed to various science articles published in reputed newspapers, magazines, so on. And it's both in English and Kannada. He has been involved in teacher training programs, science quizzes, conducting workshops for students from various parts of the country. So this is just a very brief introduction about the speaker. I heartily welcome him and I request him to start the lecture. And once again, I welcome you all and also the viewers who have joined us online. Thank you.
Hello. Yeah. Yeah. My colleagues at JNP, as well as ladies and gentlemen amongst the audience, good afternoon to all of you. Today is a special day. In addition to this lecture, at 5 o'clock we are going to give commentary in English and Kannada on the launch of LVM3 M5 and CMS-03 communication satellite. India's mighty launcher LVM3 is being launched today at around 5:30 from Sriharikota, and the live streaming of this launch, I'm going to give commentary on that in English and Kannada both. Okay, that's what we have been doing for quite some time. And now, without wasting much time, because only we have 50 minutes, in the past 2 years we have started one program, lecture series called Benefits from Space. Under that we had many lectures on Mercury, Venus and Mars already, and even on the Sun. Okay, now today we are having a lecture in that illustrated lecture series on Jupiter. The title of this talk is Jupiter, King of Planets and its Family. Before I start the lecture, let me thank my JNP colleagues. Ravi is there, who has done a lot for today's streaming as well as for other things. Srinivas is there, Dr. Anand is there. These three have done a lot for making this lecture in this form. Okay, all of them once again I thank. And let me start the lecture without much delay. See, Jupiter, I have titled it as the king of the planets and its family, because why did I term it like that, or why did I give that title? The reason is very simple, because Jupiter is a mighty planet, I would say, because how big it is, how massive it is, if you were to think of it, it is next to impossible for us. Other than Venus, Moon, Venus and sometimes Mars, Jupiter is the brightest object in the night sky. I'll take you on a journey to Jupiter. Believe me, some good visuals are there, no doubt about it. Otherwise I can go on talking and it will be boring, I'm sure about it. That is why, look at that. Now let's not delay. See, today we live on the third planet in the solar system. the Earth. Okay, the first planet is Mercury, the second planet is Venus, the third one is Earth, fourth one is Mars, fifth one Jupiter, sixth Saturn, seventh Uranus, eighth Neptune. Pluto is no longer called as a planet, it is known as a dwarf planet. Okay, so in addition to planets, we have comets, we have asteroids, we have satellites, and such things are there, meteorites and such things. Now, these are the eight planets of the solar system, Mercury to Pluto. Look at that, actually in this sizes are not shown properly. Everything is, the size of the Earth is quite exaggerated compared to that of Jupiter and Saturn, Uranus and Neptune. Okay, now let us see how big are outer solar system planets. Okay, as I told you, in the inner solar system we have 4 rocky planets. Okay, they are known as terrestrial planets, that is Earth-like. At least fortunately you can stand on them. I can stand on Earth. Similarly, I can stand on Venus, I can stand on Mercury, I can stand on Mars. That is not the case with Jupiter or Saturn or Uranus or Neptune. There is no solid surface for them. That's why Jupiter and Saturn, they are known as gas giants. Once upon a time, all the 4 were known as gas giants, but now these 2 are known as gas giants. The other 2, Uranus and Neptune, they are known as ice giants, in fact. Now, let us look at the distance involved. See, unless I relate it to daily life, you will never understand crows, slag, this, that, that's all. One will go nuts. Let us express the distances in the units which we know. For example, Mercury is at a distance of 6 crore kilometers from the Sun. 6 crore kilometers from the Sun. Venus, 11 crore kilometers. Our Earth, we are at a distance of 15 crore kilometers from the Sun. Okay, on the average, everything is on the average. Mars, 23 crore. Jupiter, 78 crore. Saturn, 6 crore kilometers from the Sun. 6 crore kilometers. Uranus, Venus, 200 crore. 200. Our Earth, we are at a distance. And Neptune, 450 crore. Pluto, let's not bother. Look at that. Mercury, Venus, Earth, Mars in terms of distance, 6 crores, 11 crores, 15 crores, 23 crores. But Jupiter, between Mars and Jupiter, there is a big gap, 78 crore kilometers from the Sun. Okay, Saturn is twice as far away from Jupiter as Saturn is twice as far away from the Sun, extremely sorry, as Jupiter is, and Uranus nearly twice as far away from the Sun as Saturn is. Neptune is the same also. So enormous distances separate, and sizes and the kind of conditions on the surface of these planets. I don't want to go into detail because I'm talking about outer solar system. See, as I told you, Jupiter, Saturn, Uranus and Neptune, these are the 4 planets in the outer solar system. The distance of separation between them is very, very large, I told you. In addition to that, look at the Earth. This is the real size of the Earth compared to Jupiter. Real size of Venus compared to that of the Earth. Mars. So, Earth is there. 90% of the diameter of the Earth is Venus. About 60% is Mars. 40 to 45% is Mercury. But Jupiter is enormous. Let me tell you, the diameter of Jupiter is more than 11 times nearly 13 times the diameter of the Earth. That means if the diameter is more, then you can fill 1,300 Earths inside one Jupiter. Can you imagine? 1,300 Earths in a single Jupiter. Such a huge planet it is. We can't even. It's a failed star to a certain extent. And it is so far away, light takes 43 minutes to reach Jupiter from the Sun. It reaches within 8.5 minutes to Earth. But 43 minutes to Jupiter. Still far away is Saturn and such things. So, Jupiter is enormous. What about the mass of the Jupiter? Mass means the amount of material contained in it. Mass of the Jupiter is 318 times the mass of the Earth. Volume is 1300 times. Mass is 318 times. So that means density of Jupiter is less compared to that. Look at that. This is Jupiter, an enormous ball of hydrogen and helium for the most part, 80%. Look at that. So this is Jupiter, the mighty Jupiter, and the mass of the Jupiter is more than twice the mass of all the planets in the solar system. Twice the mass of all the planets. You add all the masses except Jupiter, all other 7 planets. This is 2.5 times that. That's why I said it's a failed star. Probably Jupiter, if it were to have 75% more mass, it would have become a star. It has not. Okay, look at that. Look at the size of the Earth. Again, I am showing. Unless I tell you this, you will never appreciate. It looks like a dot of light in the night sky. Okay, look at that. There is the moon, there is the Venus, and here is the Jupiter. As I told you, I repeat once again, after moon and Venus and sometimes Mars, Jupiter is the brightest, I would say. And Jupiter is named after the king of the planet in the Greek and Roman pantheon. Okay, in the Greek and Roman cultures. In the ancient Greek culture, the king of the gods was Zeus, not J-U-I-C, it is Z-E-U-S. Zeus, it is pronounced. Okay, the same god in the Roman pantheon, it is called as Jupiter. Okay, Jupiter is the king of the planets. When they named it, they never knew that it is so big. Because this was thousands of years back. Rome was there. Rome was at its best 2000 years back. Greece was much earlier to that. Okay, that is the thing. In our culture, it is known as Bruhaspati. Okay, or Guru. Guru or Bruhaspati. That is why Guruvara is also known as Bruhaspati Vara. So, though it is very difficult to pronounce, that is why the most popular way, okay, the corrupted form of that is Bestvara. That is the kind of thing which people use, okay, rural people and such people. But anyway, Jupiter was earlier associated with fire. Jupiter was later in Vedic literature, it is associated with the planet Jupiter. Okay, see, for a long time, for thousands of years, people looked at Jupiter with their naked eyes. In fact, it was bright and it was moving. You know, ancient Greeks, they saw 5 dots of light which they named Mercury, Venus, Mars, Jupiter and Saturn. Okay, all of them, they called them planetes. That means wanderers, from which the word planet has come. Okay, these 5 dots of light, including Jupiter, they appear to move, not hour to hour, but from week to week, they appear to actually move in the night sky against the background of fixed stars. But Galileo Galilei was the first person to observe Jupiter through a telescope. Okay, this is the thing. And you take a small telescope or even a binocular. When Jupiter is visible, focus it towards that. Point it and focus it towards that. You will see many a times 4 dots of light surrounding Jupiter. They are the largest satellites of Jupiter, called Galilean satellites. Okay, there are 4 satellites: Io, Europa, Ganymede, and Callisto. These are the 4 ones. See, when Galileo Galilei first turned his telescope, small crude telescope, towards Jupiter, he saw these 4 dots of light and they were circling Jupiter. That is, they changed their position with time. What did it indicate? As per the earlier belief, everything in the night sky has to go around the Earth, because Earth is special. Human beings are there on that, so everything has to go around that. Of course, intuition also says the same thing, but that is not true. But anyway, Galileo's sight of the Galileo, whatever we call as Galilean satellites, in 1610 AD, it gave way to the great scientific revolution. And look at bigger and bigger telescopes when they were built. For example, this is Mount Palomar Observatory. From there, they have taken the picture. There was one great person, M.L. Humason. Okay, he has contributed a lot to astronomy. You can see that faint bands are there on Jupiter, you can see. But today, with an 8-inch telescope, 8 inch means not length. 8 inch is the width of the primary mirror of the telescope. Okay. With that small telescope, you can actually look at Jupiter. This is a beautiful picture of Jupiter. Yesterday it was given to me by Mr. Ravi Aradhya, who is the president of Amateur Astronomers Association of Bangalore. Thanks to him. Look at that. This is the 8-inch telescope picture of Jupiter. This is the way you can say. You can see one of the Galilean satellites there. Meanwhile, you know how many satellites are there for Jupiter? At least 95. At least 95. We have only one natural satellite, our moon. Anyway, lots of reports are coming. One more moon is there and all those things. That is different. But anyway, for the past 400 crore years, scientists say that at least one moon is circling us. That is our moon. Mercury doesn't have any moon. Venus doesn't have any moon. Earth has one. Mars has two. Small potatoes kind of thing. Jupiter at least 95. Saturn at least 274 or 146, depending on the way who is telling. Okay. Uranus at least 29. Neptune 14 or 15. Okay, that's it. So, but anyway, 4 of the large satellites of Jupiter are Mercury, Venus, the thing is Io, Europa, Ganymede and Callisto. These are the 4 Galilean satellites. This is a picture of Jupiter taken from Keck telescope in Hawaii. Nowadays, you know, telescopes are getting better and better, but there is a definite upper limit beyond which you cannot go. Can we play that space bar? See, robot.
Live at NASA's Kennedy Space Center for NASA's Europa Clipper mission, a nearly 2 billion mile, 5.5-year journey to Jupiter's icy ocean.
And liftoff. Liftoff, the Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa.
By booster separation confirmed.
Fairing is separated, and those will be recovered by SpaceX's own recovery ship, Go Cosmos.
This is a big moment for the program, for NASA, APL, and JPL. Let's watch.
Europa Clipper, separation confirmed.
And there you go. NASA's Europa Clipper probe, embarking on a long-awaited mission to study Jupiter's icy moon, Europa. And what a sight.
Now they wait for acquisition of signal.
I believe we have it. There it is. Confirmation of signal from the spacecraft Europa Clipper.
Okay, this is the thing. So next one, again you press that. Sorry. See, from to different planets. In 1962 itself, a spacecraft called Mariner 2, it went near Venus. In 1965, Mariner 4 went near Mars, and of course, in 1973, Pioneer 10 went near Jupiter, and 74 Mercury, and 79 again Saturn, and 86 Uranus, and 89 Neptune. Okay, Voyager 2 spacecraft. So all the planets of the solar system have been visited by robotic spacecraft, and they have revolutionized our understanding of the solar system as such. That is why benefits from space, again and again I am telling, there is an upper limit to which you can sense about solar system objects from the Earth. If there is something we know which is significant, it has come from spacecraft. And India is not lagging behind. I want to say that as Indians we have to be proud. We have explored Mars, we have explored Moon, and we are exploring the Sun, okay, even now. So we are going to Venus also, okay. Look at that, there are different instruments which these robotic spacecraft carry to study different aspects of a heavenly body, whether it is Jupiter or Mars or whatnot. This was Pioneer 10, this was the first spacecraft. This was the first spacecraft to travel towards Jupiter. Between Jupiter and Mars, there is a vast gap, okay. In between that gap, there is what is known as asteroid belt. Asteroids are small bodies which appear to be the pieces of a planet which exploded, which appear, but scientists say they are really the pieces of a planet which never was formed. Okay, that's the way it is. Yes, and whether will we be able to cross Jupiter asteroid belt before Jupiter? Nobody knew. Asteroids may come and hit the spacecraft and we are stuck on Earth. Up to Mars only we can go, they were thinking. In 1972 this was launched, Pioneer 10, and 1973 it crossed the asteroid belt and it went to Jupiter. And in next year they launched Pioneer 11 and it went to Jupiter again in 74 and went towards Saturn. Anyway, let's not worry today. Then Voyager spacecraft, 2 Voyagers, they were launched in 1977 and both of them, they went to Jupiter in 1979 and that is the, this is Voyager 1 and 2, they look alike. And anyway, I am going to give a talk on Voyagers themselves, which is very interesting. And we are now readying one sky show about Voyager spacecraft. That is fantastic. We are adding something else also on that. Okay, and there was another spacecraft called Ulysses, okay, that went towards Jupiter. Not much was done by that spacecraft because it wanted to go and study the poles of the sun. Okay, it was called as International Solar Polar Mission. Then Galileo spacecraft, okay, named after Galileo Galilei. It went to Jupiter in 1995. You know, Galileo Galilei, for furthering science, for taking the cause of science and its development, he had to suffer a lot. He had to suffer a lot. He was even showed torturing instruments, in fact, for telling that Earth goes around the sun. Okay, the spacecraft which was named after him also underwent so many problems. Ultimately, it triumphed. Anyway, there is a separate talk I am giving on Galileo spacecraft. What it suffered, it is as much of a science as it is engineering. Okay, anyway, then Cassini. Okay, this was a great person, I mean one of the greatest astronomers. Actually, he was born in Italy and went to France, Jean-Dominique Cassini. Okay, a spacecraft named after him passed near Jupiter and got information. And this is Juno. Okay, this is yet another spacecraft which is still, even today at this moment of time, it is orbiting Jupiter. See, 95 natural satellites, one artificial satellite is there on Jupiter, launched by humans. Okay, then this is called New Horizons. This is a spacecraft which was launched to explore Pluto. The paradox is, when this was launched, Pluto was called as a planet. By the time it went out of the Earth and it was traveling on the way, Pluto was demoted to the status of a dwarf planet. Anyway, planet or dwarf planet, demotion or promotion, it didn't matter. It went and fantastically observed Pluto. Anyway, at a later stage, let us see that. And of course, Earth orbiting Hubble Space Telescope. It is circling the Earth at a height of 600 kilometers. It is also studying Jupiter. Who said no? And this is James Webb Space Telescope. Though it was destined to study the cosmos as such, it can study our solar system bodies. Of course, nobody is there enough to turn it towards the sun. It gets burnt up. That's all its optics. So anyway, it can turn towards Jupiter. It has also turned. I will show you the pictures. Now again, going back, Pioneer 10. Okay, this is the thing. This was launched in 72. You can see the engineers there who have built it. This is the one, and this is the one it is carrying. A lot of instruments. There is no time today to say that. It crossed the asteroid belt in 73 and went to Jupiter in 1973 itself. Okay, and this is a painting showing the crossing of asteroid belt by Pioneer 10. Look at that. This was the picture of Jupiter progressively getting clearer and clearer as sent by Pioneer 10. Okay, this is the Pioneer 10, and this was the best picture sent by Pioneer 10 of Jupiter. Not much was. Anyway, we could able to reach Jupiter, and one thing was, it discovered one thing, that it proved we can pass through the asteroid belt. The second thing is, Jupiter has a very, very powerful magnetic field, and the radiation surrounding it can kill a person within hours. But the spacecraft survived and paved the way for other spacecraft. Very carefully, by targeting them, can make them to live, shielding them and such things. Okay, this is the picture of Jupiter, another picture of Jupiter by Pioneer 10. This is one of the Galilean satellites. This is Europa and this is Ganymede. And this is Pioneer 11 going near Jupiter. This is only, of course, this is Voyager 1 spacecraft, and this is the one which went in 1979 in Jupiter, Voyager 1 and Voyager 2, 1979 and 1979 only, both of them. And Ravi, can you please, next slide, can you put that space bar? Look at that, this is an animation of Voyager 1 spacecraft going near Jupiter. Look at the way in which it rotates. Okay, so it can do any kinds of somersault to observe what you want or to get information what you want. Look at that, the picture of Jupiter was taken by a Voyager spacecraft as it neared that, and by combining the images, now you can see how dynamic the atmosphere of Jupiter is. Nobody could able to sense this much of violence is there in the atmosphere of Jupiter. It is so dynamic. Look at that. And there was a thing called Great Red Spot which people had observed for 300 years. What it was, nobody knew. And even if you look at Jupiter, in our telescopes we have seen in the planetarium, see, if you look at it, you can see dark bands known as belts and light bands known as zones. So these things you can see around Jupiter, but actually as to how much of movement is there in that, what is the wind speed and such things, nobody knew, but people really got, even first scientists got surprised, and common man, really could not comprehend as to what was there. Look at that, this is yet another picture of Jupiter taken by Voyager, and this is the picture of Great Red Spot. You know how big it is? This is supposed to be a cyclonic feature, in fact, okay? A storm, I would say, more than cyclone, a storm kind of thing. You can fit in 2 to 3 Earths inside. So huge is the Great Red Spot. Look at that. And one more thing was, Voyager spacecraft reported that Jupiter is also endowed with 4 rings. Rings means we always think of Saturn. Saturn is called as the jewel of the solar system because of its enormous rings and very conspicuous rings. But what about this Jupiter? Jupiter also was found to have 4 rings, but they are not as conspicuous or as eye-catching as the rings of Saturn. And Uranus and Neptune also have rings. None of them are visible very prominently, but the rings of Saturn only are visible. And look at that, we thought about, we talked about the radiation belt of the belts of the Jupiter, okay? Then its atmosphere as such. Then let us worry about what Jupiter is made of. What Jupiter is made of. Earth is made mostly of, okay, to a certain extent on the surface, silicon, iron, nickel, and such things. Okay, silicon dioxide, sand. But what Jupiter is made of? Jupiter is 80% hydrogen and helium. Hydrogen is the lightest element, and the second lightest is helium. In fact, 80%. Of course, but its atmosphere contains ammonia, ammonium hydrosulfide, as well as water. The colors which you see is due to phosphorus and sulfur compounds which have come from down below. In fact, that is the reason. And Jupiter, we say, those people who speak Kannada want to say something. Jupiter doesn't have a solid surface, I said. So it is a fluid planet, in the sense gases and liquids. So actually, you can't stand on Jupiter. The atmosphere is there. That is like clouds and storms and such things. If you go down, it is slowly it becomes liquid. Then can you do boating on that? By chanting a song called Doni Sagali Munde Hogali, like that. No, it is not possible, because The gases go on increasing in their density and ultimately they become liquid. And you go still down, down and down and down, then hydrogen takes the form of a metal. Rather, it behaves like a metal. The way in which Jupiter, okay, let me tell you one more thing. Jupiter is spinning very fast, and this metallic hydrogen, because of its presence, it generates a powerful magnetic field. I told you it can kill people, in fact, in hours. Such dangerous it is. Jupiter, on the average, is at a distance of 78 crore kilometers, or 780, almost nearly 780 million kilometers, I said. So it takes only 11.9 years to go around the sun once. 11.9 years. 1 year on Jupiter is 11.9 years. But Jupiter spins around its own axis very, very fast. In fact, it is the fastest in the solar system. It is in 9 hours 58 minutes. That's all. So that is why, you know, the thing is, the magnetic field is very, very powerful. First is metallic hydrogen, and ultimately there is a earth-sized or even better than that, a rocky core is also there. So these are the things which, who has gone inside and seen? Nobody has seen. But getting the data and extrapolating and using the scientific laws and mathematics, these things have been found out. Look at, this is the magnetic field of the Jupiter, and you can see the 4 large satellites of Jupiter which are known as Galilean satellites. They are circling almost inside the magnetic field. Okay, very, very dangerous. That is why, though Jupiter doesn't have a solid surface, but its Galilean satellites, all of them have solid surface. We cannot go and land there easily. No. Radiation environment is too harsh and dangerous. Okay, Callisto is okay somewhat. And now look at that. There are, out of the 95 satellites, at least 95 satellites of Jupiter, 4 of them are very large. They are known as Galilean satellites, I said, because Galileo Galilei was the first person to observe them in 1610 AD. One is called Io, second one Europa, third one is Ganymede, fourth one is Callisto. Okay, these are the 4 satellites. In fact, in Greek mythology, okay, Greek and Roman mythology, these are the consorts of Jupiter. Consorts of Zeus or Jupiter, in fact. Okay. So this is the thing, you can see them. Okay, one of them, sorry, Ganymede is not the one. He was supposed to have been kidnapped at the instance of Jupiter or Zeus. But anyway, other 3 are ladies, consorts of Zeus or Jupiter, in fact. They named after such characters in the mythology. Okay, look at that. Io, Europa, Ganymede, Callisto. How they circle the Jupiter. See, Io is the nearest, Europa, Ganymede, Callisto. They are going round. And look at Io. This is the way it looks. Nobody knew. They thought Io was a dead satellite, dead heavenly body. In fact, in the sun, there will not be any activity at all, they were thinking. But what happened? One of the engineers in the Voyager program, he accidentally discovered something. Later it came to be known that it was a volcanic eruption on Io. Volcanic eruption. Other than Earth, you can see volcanoes like this on Io only in the solar system. Like this, let me say. Okay, this is the way. And Voyager spacecraft, it looked at Jupiter, and it saw many of the eruptions, and you can see why there are volcanic eruptions on Io. There is a gravitational tug of war between Jupiter, Io, and the other Galilean satellites. Because of that, the tidal force acting on Io is so much, maybe 200 to 300 meters, its surface rises and falls every day. That is the reason why magma comes out, magma whatever we say on Earth, as lava, and at any time probably hundreds of volcanoes will be erupting on Io. This is the most volcanic body in the solar system. Can you find out all these things from the surface of the Earth? Thanks to robotic spacecraft, thanks to space flight, we have done all this. We know about solar system. And Ravi, one more thing. Can you, this one, I want to show you a movie, how from Io it looks, you know, Io is this one. How volcanoes are there on Io, you can see in this animation of NASA. Okay, see, one of the eruptions is already there. Okay, if you are flying over the surface of Io, let us see how will it be. Yeah, let us go to, look at the sky. It is almost filled by mighty Jupiter. You cannot even imagine such things. You cannot even imagine. Thanks to robotic spacecraft, thanks to space flight. That is why benefits from space. 100th time I am telling in this lecture. So this is the way. Yeah, that is Io. Okay, the most volcanically active of the Jovian satellites. Again, I repeat, out of 95 satellites of Jupiter, known satellites, 4 of them are very large, very large. Some of them are comparable in size to our moon, and one of them is larger than our moon. Okay, and larger than the planet Mercury itself. I'll come to that. So next satellite, Galilean satellite is Europa. Okay, Io was full of volcanoes. This looked like a golf ball. Okay, its icy surface is so smooth, you can even ice ski on that kind, if you can go there. That is different. Okay, and lot of crisscrossed features are there. Immediately scientists began this one explaining that and surmising that there is a liquid water ocean below the icy crust of Europa, and water is coming out. Wherever there is water, then scientists always suspect life. Life means not like human being, microscopic life. Yes. Once upon a time, such things could not be thought of, but in late 70s, they found 4 kilometers below the ocean, there is a thriving ecosystem of worms, bacteria, and such things. So they are called as extremophiles. Why can't such life forms be there below the icy crust of Europa? That is why Europa is one of the likeliest places in the solar system where we may find microscopic life. Okay, and the next satellite is Ganymede. This is the 3rd Galilean satellite. You know this, how big it is? Bigger than our moon, Ganymede, and it is bigger than planet Mercury itself. Ganymede is a satellite of Jupiter, but it is bigger than the planet Mercury. Okay, so this is also suspected to have a ocean below its icy crust. Okay, and the 4th one is Callisto. It is full of craters on, nothing. Okay, no activity for a long time, crores, I mean hundreds of millions or even billions of years, at least a few billion years. It doesn't seem to have any geological activity or resurfacing, that kind of thing. Look at that. This is one of the greatest pictures sent by Voyager. It is called as Valhalla. So this is a concentric feature which is there on Callisto. And nearer to Jupiter than all these 4 satellites, there is another satellite which is only 500 kilometers in diameter. It is called as Amalthea. Okay, look at that. Amalthea was a nurse who fed Jupiter, in fact, in the Roman mythology, I would say. So that is the name. Look at that. This is the picture of Jupiter sent by James Webb Space Telescope. You can see the faint rings of Jupiter. You can see there is one more satellite, nearby satellite called Adrastea, Amalthea, and there are, you see, in the polar areas of the Earth, we have what are known as auroras, and like that, much bigger things are there in Jupiter also. And as I told you, there was another spacecraft called Ulysses, which went, but it could able to study only the magnetic field of Jupiter. So Galileo spacecraft, I'll give some more details. It suffered a lot, as much as the Galileo himself. Okay, but anyway, ultimately it triumphed. Okay, and look at that. This is an animation of Galileo spacecraft near Jupiter, thanks to NASA. And again one more, sorry, I think see, Galileo spacecraft, when it neared Jupiter, before it started orbiting Jupiter, it sent a small capsule, a probe, into the atmosphere of Jupiter on a suicidal mission. Okay, they knew that it's going to be destroyed, but before that they wanted to collect as much information as possible. I told you Jupiter's atmosphere, especially the top clouds, first is they were thinking ammonia, ammonium hydrosulfide, then water. Okay, it just went into let us say up to 200 kilometers or something like that, maybe a little less, and then it got destroyed. Okay, next one. Again, can you press that? Okay, I myself can do it, sorry. Look at that, this probe which was released by Galileo spacecraft before it became an artificial satellite of Jupiter. This probe went towards the atmosphere of Jupiter, because this kind of thing is called in situ observation. That means it goes and from the same place it collects the data, not from a distance. Remote sensing, not like that. So look at that, the way in which it is going there. Okay, it is entering the, look at that, this is the way probably the clouds look to this probe, such thick clouds. Okay, and look at that, it is going there. For about 58 minutes it was sending information. 58 minutes it was sending information, then burst. It got crushed and incinerated in the extreme temperatures and pressures which were present there. 58 minutes it sent information via Galileo spacecraft. See, these are the things. So thanks to spaceflight. Okay, look at that, how it's going. This is still the heat shield. Okay, heat shield is protecting the probe and its instrument. At one point you will see, look at that, a parachute will open. Yeah, it has opened. Now it is descending down and down and down and down slowly, and ultimately got destroyed. After 58, they could able to get 58 minutes of data. I still remember I was in ISRO, I was busy with one of our satellites called INSAT-2C at that time. So I found time and I was following this also at that time. This was 33 years back. I still remember, 33 years back, December 1995. Okay, this is, look at that, the horrible conditions there. It got destroyed. Okay, this is an animation kind of thing, of course, which helps us understand it. Look at that, this is the great red spot on Jupiter. I told you it is a giant storm which is 2 to 3 times the size of the Earth. Look at that, slowly how counterclockwise direction it is spinning. Okay, it has survived for 300 years. Okay, and this is the way Io with lot of volcanoes look to Galileo, and look at that. I want to carefully see, I want you to carefully see this picture. So how does it look, these colors? You remember something else? I'll show you something. Okay, this is of course eruption of different volcanoes is shown by Galileo. And anyway, how does it look? It looks exactly like that, a pizza. Okay, this is a look at the colors in a pizza. Okay, these colors, and sorry, yeah, look at that, and look at the color of pizza. It resembles pizza in its color, no doubt about it. Why? Because of sulfurous or phosphorus compounds, scientists say, in fact, this yellow color and red color and such things. Not in the pizza, but on Io. Okay, pizza it is, cheese, of course, it is different. Of course, this is Europa. You can see the way in which the stripes are there. That is, this is the place where probably water would have come from below and refrozen, somewhat like that. And this is Ganymede and Callisto. This is not Ganymede, this is Callisto, actually seen by Galileo spacecraft. Once its mission was over, it orbited Jupiter between 1995 and 2003, and deliberately it was sacrificed. In the sense, it was made to enter into the atmosphere of Jupiter and get itself destroyed. Why? There is a reason. Nobody wants to contaminate Europa. It is having a pristine surface. Nobody has disturbed it for billions of years. A spacecraft which has not been sterilized, if it were to go and hit Europa and contaminate with earthly life, after some time you go and see something and life is there, you may say, but that might be earthly life. or don't contaminate. This is not ethical. That is what they think. Okay, anyway, this is Amalthea, near that Jupiter, how it is. Look at that from Amalthea, how the sky looks. Here, the moon and sun are of a size which we say 0.5 degrees. But from Amalthea, if you stand there on its surface, let us say hypothetically, 46 degrees is the width of the Jupiter's orb, that is disk. So this is Amalthea. It is photographed by Galileo. And Galileo did one more thing. You know, many people may remember in 1994, a comet called Shoemaker-Levy 9. It neared Jupiter. Because of the enormous gravitational force of the Jupiter, the comet broke into 24 pieces. All of them, they went and hit the Jupiter. If the same thing were to occur for Earth, it would have been finished. But for Jupiter, it didn't matter at all. Look at that. See, you can see the this is not the nearing of cometary pieces to Jupiter, but this is, you see, only this is the sunlit part of Jupiter. This is the dark part of the night part of the Jupiter. But anyway, when the pieces of Shoemaker-Levy comet hit it, you can see the explosions in the atmosphere of Jupiter. This was a fantastic event which happened, again I said, nearly 35 years back. And look at that, this picture of the atmospheric circulation of Jupiter was taken by a spacecraft called Cassini. Okay, this is a NASA spacecraft, of course named after a great astronomer. And now even today there is a spacecraft which is circling Jupiter. It is called Juno, a NASA spacecraft. You can see this is the way it is. It looks quite different compared to Voyager, Galileo and Pioneer. And now you can see the way in which it is observing Jupiter as it comes very near to Jupiter in fact. And you can see very, very clear pictures of Jupiter, because you know each succeeding generation of spacecraft has better technology to observe. Okay, this is the great red spot as seen by Juno, and this is the southern hemisphere of Jupiter. Look at the clarity. In fact, this is the way. I am showing you only popular things. Scientists discern many other things from this. And this is Io. Once again, a lot of volcanoes are there. Then you can see how many volcanoes. All of them are erupting. This is the picture of Io taken by Juno spacecraft. You can see how many volcanoes are there. They are erupting at the same time. And this is Amalthea. Actually, this small dot is here and here, taken by Juno spacecraft. This is the picture of Europa, taken by Juno spacecraft. Ganymede, and another picture of Ganymede. And I told you a spacecraft was sent to explore Pluto. It was called as New Horizons. On the way to Pluto, it passed Jupiter and it observed Io, and you can see the eruption of a volcano. Okay, can you see that? So nicely it is there. And as I told you, auroras are there in the polar areas of Jupiter. And you can see this is taken by Hubble Space Telescope, and this is the picture of Jupiter taken by James Webb Space Telescope. Look at that. There are two spacecraft today which are proceeding towards Jupiter. Two spacecraft. One is called as JUICE, J-U-I-C-E, JUICE only. It is not fruit juice kind of thing. Jupiter Icy Moons Explorer. That is the name of that is an acronym. Okay, it is on its way to Jupiter. And it will study not only Europa, where a subsurface ocean is there, they suspect, and of course Ganymede and Callisto. All the three are icy moons. They want to study, European study. Of course, NASA is also involved, and NASA itself has launched a spacecraft towards Europa. You see how much of importance is being given to Europa. Okay, so this is the one. It is called as Europa Clipper. This is also on the way. Europa Clipper was launched in 24, JUICE was launched in 23. Both of them are proceeding towards Jupiter. They are on the way to Jupiter. And of course, I told you, look at that. There is an ocean which is suspected to be below the icy surface of icy surface of Europa. What will we find? This is a imaginary diagram actually provided by NASA. Look at that. This is the way probably chemicals are coming out of that and ecosystem may thrive. Such things, believe me, on Earth, they are there. There is in the United States, in California, in San Diego, there is a institution called Scripps Institute of Oceanography. They went on an expedition and such extremophiles, maybe 2, 3, 4 kilometers below, they could able to find. So look at that. This is a future landing on not Io, not Europa, not Ganymede, but Callisto. Compared to Europa, Io, Europa and Ganymede, Callisto is safer for humans to land. So it was told that by 2050 or so, we will have the technology to land there, but I don't know how much of money is there for such things. But anyway, if humans themselves will go, yes, that is an additional information, and that will be a very significant one for humans. So Jupiter actually, it is the king of the solar system, king of the planets. Okay, forget about the sun. Other than sun, Jupiter is the king of the planets. The entire Jupiter system is like a mini solar system. So to understand Jupiter, by understanding Jupiter, we will understand the origin and evolution of the solar system, including our own Earth-Moon system. Thank you very much for your patience, and I hope I have given you a brief glimpse. If I go into more details, you will get bored. In fact, I am sure about it. But at the same time, I have not told only this much, this is this, like that. There is a reason for everything, in fact. If you have any questions, if I am able to answer, definitely I will do. In the next 5 minutes, we will do that. After that, we want to show the live telecast of the launch of CMS-03 satellite from Sriharikota today. Any questions? Please. Yeah, please, sir. Sir, my focus and my knowledge is about astronomy, sir. I don't know anything about astrology. Guru Bala is the word I have also heard. See, that is the kind of strength which Jupiter provides, Guru provides, they say. I don't know really. My name is Guruprasad, but I want to be called as Prasad, not Guru. Okay, so all said and done, that is a different domain, sir. I don't have any knowledge on that. Please.
My name is Ramesh Kumar, sir.
Yeah.
No, Haveri district Rettihಳ್ಳಿಯಿಂದ KSET ಎಕ್ಸಾಮ್ ಬರೆಯಕ್ಕೆ ಬಂದಿದ್ದು. ಜಿಯೋಗ್ರಫಿ ಲೆಕ್ಚರ್ ಆಲ್ಸೋ ಸರ್. ನಾವು ಟೀಚ್ ಮಾಡಬೇಕಾದ್ರೆ ಗ್ರಹಗಳ ಬಗ್ಗೆ ಟೀಚ್ ಮಾಡ್ತಿರ್ತೀವಿ. ಆ ಟೈಮಲ್ಲಿ ಬಿಗ್ಗೆಸ್ಟ್ ಗ್ರಹ ಗುರುಗ್ರಹ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೇಮ್ ಥಿಂಗ್ ಮೈಥಾಲಜಿಲೂ ಅದೇ ರೀತಿ ಬರುತ್ತೆ. ಬೃಹಸ್ಪತಿ ಈಸ್ ಎ ಬಿಗ್ಗೆಸ್ಟ್, ಯಾಕೆಂದರೆ ಆ ರೀತಿಯಲ್ಲಿ ಬೃಹಸ್ಪತಿ ಗುರು ಅನ್ನೋ ಗ್ರಹ ದೇವತೆಗಳಿಗೆ, ಆಮೇಲೆ ಶುಕ್ರ ಅನ್ನೋ ಗ್ರಹ ಶುಕ್ರಾಚಾರ್ಯ ಅಂತ ಇದು ಬರುತ್ತೆ. ಅದೇ ರೀತಿಯಾಗಿ ನೀವು ಲಾಸ್ಟಿಗೆ ಹೇಳಿದ್ರಿ ಯಾವುದು ರಾಹು, ಇದು ಯುರೇನಸ್ ಮತ್ತು ನೆಪ್ಚ್ಯೂನ್ ಪ್ಲೂಟೋ ಅಂತ ಬರುತ್ತಲ್ಲ ಸರ್, ಅಲ್ಲಿ ರಾಹು ಕೇತು ಅಂತ ಹೇಳ್ತಾರೆ. ಇದಕ್ಕೇನಾದ್ರು ಸೇಮ್ ಲಿಂಕ್ ಇದೆಯಾ ಅಂತ?
ಓಕೆ, ಯಾ ಸರ್, again you are going into something which I don't have knowledge. Okay, see, Guru, they might have given this Bruhaspati or Guru. I don't know what was the reason. At least I don't know much
geography
about this. But Jupiter is bright, no doubt about it, very bright. Okay, but brighter than that is Shukra, Venus. That is why probably Shukra, they say, might have come. Okay, could be. These are all, you have to see it from anthropological point of view, sociological point of view, okay, emotional point of view. I don't know about this one. But anyway, when it comes to Shani, in fact, one great gentleman by name G. Venkat Subbaiah, Professor G. Venkat Subbaiah, who lived for 100 years, he told me why Shani was called as Shani means Shanaischaraha means slowly moving one. Amongst the 5 dots of light, Mercury, Venus, Mars, Jupiter and Saturn is the relatively slowest. That is why it was called as Shanaischaraha. That is the astronomical point. About this Guru Bala, Shukra Dese, I don't know much, sir. Please.
ಸರ್ ಅದೆಲ್ಲ
Sorry.
ನನ್ನ ಕ್ವಶನ್ ಇದ್ದಿದ್ದು ಏನಂದರೆ ಈಗ ನೀವು ಎಲ್ಲರೂ ಹೇಳಿದ್ರೆ ನಮ್ಮದು ಯುರೋಪಿಯನ್ಸ್ದೇ ಜಾಸ್ತಿ ಬರುತ್ತಲ್ಲ, ಯಾಕೆಂದರೆ ನಮ್ಮ ಭಾರತೀಯರ ಕೊಡುಗೆಗಳನ್ನು ಜಾಸ್ತಿ ಇದೆ. ಆಲ್ಮೋಸ್ಟ್ ಫಸ್ಟಿಗೆ ಭಾಸ್ಕರಾಚಾರ್ಯವರು ಅವ್ರು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದಾರೆ ಆರ್ಯಭಟಿಯ ಸಿದ್ಧಾಂತದಲ್ಲಿ, ಆವಾಗಲೇ ಭೂಮಿ ಬಗ್ಗೆ, ಭೂಮಿಯ ವ್ಯಾಸದ ಬಗ್ಗೆ. ಅದು ಯಾಕೆ ನಮ್ಗೆ ಜಾಸ್ತಿ ಇನ್ಫಾರ್ಮೇಷನ್ ಬರಲಿಲ್ಲ?
No, it is not like that. Whatever, see, if whatever we know, if it has not been told, probably it is not correct. But let us not claim at the same time something which is not done. But I am very proud. Aryabhata, 15 centuries back, he told, day and night are caused by the diurnal motion of the earth, that is spinning of the earth about its axis. Similarly, ಗ್ರಹಣಗಳಾಗೋದು ಯಾಕೆ ಅಂದರೆ ಗ್ರಹಣಗಳಾಗೋದು ಬೆಳಕು ನೆರಳುಗಳ ಆಟದಿಂದ, ಅಂದರೆ light and shadows. Okay, they were responsible. If we don't understand that, it is our fault. Whatever we have done today, modern India has achieved a lot. Let us be proud of it. Whatever we have achieved, let us be proud, no doubt about it, and let us try to give importance for that. Okay, yeah. Any other question? So yes sir.
Hi sir, thank you for the session. So I have two questions.
Yeah.
If the gravitational pull is so strong on Jupiter, how do we send spacecraft near it? Because between the satellite and the planet, the gravitational force is so strong. So do we keep the spacecraft away from the satellite? That's the first question. The second question is, how do you define a atmosphere on a gaseous planet? Like on Earth, I understand it's from the Earth and whatever, like 50 kilometers or 100 kilometers. How do you define atmosphere on Jupiter? Thank you, sir.
Thank you very much. Fantastic question. Both the questions. Second one is more difficult than first one. See, the spacecraft are targeted very carefully. If you make them to go very near to a planet, let us say, okay, then they may not be able to escape. Probably they may hit the surface of that planet also, whether it is gaseous surface or solid surface or liquid surface. Okay, for example, I will give you one instance, tell you one instance. In the United States, one spacecraft called Mars Climate Orbiter was being targeted towards Mars, planet Mars, in 1997 or 1999. Okay, they were targeting. People who were controlling the spacecraft were NASA people. People who had built it were Lockheed Martin people. Okay, that's a private company. One was using metric system, the other one was using FPS system. So if you don't calculate properly, instead of going into an orbit around Mars, it fired its rocket engine in the wrong direction and hit the planet. So very carefully you have to target the spacecraft as to, the gravity field of the planet. So if you want it to be captured into an orbit in one step, it is not possible. You have to slow it down much further. That is what we have done in the case of Mars orbiter Mangalyaan mission. Okay, so we have to be extremely careful, but target it away from the planet. So instead of passing straight, its path gets deflected. That is first question. Second thing is, where is the atmosphere? How thick is the atmosphere? Probably, they define it to a certain extent. What is the temperature and pressure in the Earth's atmosphere at the ground level? Somewhat like that. That is one of the classifications. But anyway, I told you, it is not easy for us to, there is no clear-cut demarcation between where the gaseous state ends and where liquid begins. There is a puzzle here. So it is not easy. Probably this is one of the good questions. Very good question. Yes, those two girls there. Quickly, at least 5:15 we will start this. Yes. Take the mic. See, that is what I want the children to ask us. Yes.
Thank you for this session.
Thank you.
So I have a question about the satellite. When the satellite comes near the Jupiter, there's a red dot.
Yeah.
So I heard that it's full of storms.
Yes.
So what if the storms destroy the satellite?
No, we don't send that much near that. Okay,
Oh.
they are quite far away. For example, Voyager spacecraft, when it took the pictures, Voyager 1 was a distance of nearly 3 lakh kilometers from there, and Voyager 2 was twice the distance. And Galileo spacecraft has gone very near to Jupiter, but it was moving so fast, again it could able to come back. Their path was very carefully planned. Good question. That's what I appreciate. Yes, that girl there. Yes, good.
Actually, I wanted to ask that how is a Jupiter formed?
I have to go back at least 450 crore years back. Good question. Yes, that's the way. At her age, he is asking. Okay, how Jupiter was formed?
Yes.
How Jupiter was formed was similar to how Sun was formed. Okay, once upon a time, more than 450 crore years back, there was a huge cloud of gas and dust called nebula. Cloud means not the kind of clouds you see in our vision. Huge, huge, huge. You cannot even imagine. Humongous. Okay, that one, it started collapsing upon itself. Already it had some small rotation, and to conserve the angular momentum, it started rotating much more faster. Then the central portion became the sun, that is the cloud of gas and dust, they accumulated and became sun. Whatever was there, some small eddies like whirlpools were there around that, they became planets. Okay, they also were formed somewhat like that, not with the same material, but whatever material was there at different distances from the sun, from that they formed, and Jupiter was the first planet to be formed after the sun. That's what scientists say. Whatever way the sun was formed from hydrogen and helium, the same ratio is there even in Jupiter. Okay, that is the way, by the accumulation of hydrogen and helium, Jupiter was formed. Very good question. Give her a big hand today. Fantastic. Philosophical question she's asked. Yes, last question. Yeah. Yeah. You're going to become a scientist, definitely.
I know that the sun gives the light to the moon,
Yeah.
like that's how we get the light on the earth, and the sun also gives the
Yes.
light on the earth. So I know that they both help us, but then I want to know that how Jupiter helps us.
Jupiter helps us. Oh, not okay. Let me say how Jupiter helps us. What scientists say is that, there are a lot of, in the history of the solar system, many comets and rocky bodies from a distance beyond Jupiter, when they were coming and raining towards the inner solar system, Jupiter has provided a shield so that they have not come and hit the earth. All of them, not all of them, most of them. Okay, that is, in the history it has helped us. Even today it is doing the same. Otherwise, in terms of gravity and such things, Jupiter is very far. Gravity of Jupiter on Earth, when compared to gravity of the Sun on Earth, the latter one, the second one, gravity of the Sun formally overwhelms the gravity of Jupiter. I mean, its influence on the Earth. Very good question.
Thank you.
Thank you very much. I think now we can go for Ravi. Shall we have this one? Thank you very much for that good response. The thing is, interested students, young students, children, if they were to ask questions like that, that is what I want. 100 people, 200, 500 people is not important. People who are interested should be important. Okay, so that's good. How many of you know Kannada very well? Can you raise your hands? Okay, almost all of them. All of you know Kannada. Yeah, all said and done. You know about Dara Bendre, isn't it? Okay, great person. Okay, mystic poet. So somebody, when Dara Bendre got his Jnanapita, one function was arranged in Dharwad itself at university. Dara Bendre is from Dharwad only. Okay, so a lot of people were not there. So the organizers apologized to Dr. Dara Bendre that sorry sir, jasti jana barliಲ್ಲ. So in Kannada he told it him, hey Tamma, ಲಕ್ಷ ಜನ ಬರ್ದಿದ್ರೆ ಪರವಾಗಿಲ್ಲೋ, ಲಕ್ಷ ಕೊಟ್ಟು ಕೇಳೋ ಜನ ಬಂದರೆ ಸಾಕು. He told it seems like that. That is what is important. Thank you very much. Anyway, so the questions themselves speak about the attentiveness of the students and the general public also. Thank you very much. That's why we do our level best. Kindly do come for all our programs. We are doing our level best to popularize astronomy and space. We have teacher workshops, we have student workshops, we have lectures. Kindly do come for this. Thank you. Now we will have the launch, and let us see what happens. Bharat. Once again, without fail, let me thank all the people who have been responsible for this, beautiful projection. Ravi, Anand, and our Srinivas, he is very much there, and Deepak is not there. He was the person who gave me a lot of visuals. He spent a lot of time. In his absence also, I thank him. And others are also there. Sharanya is there, and many others. Okay, thank you. See, probably in the next 10 minutes or so, as it was announced, we are going to launch a spacecraft called CMS-03. It's a communication satellite, okay, that is being launched from the Indian soil, that is from Sriharikota. So it's a 4,400 kg satellite. 4,400 kg satellite. Dinakar, is it coming? Live is coming in. Yeah, started. Anyway, if there is problem with this, coming, lecture and all those things came. You can use the other laptop if you want. Oh, but Anand, shall we have one more? Do we have one more laptop? Yeah, but you are streaming it, Just kindly bear with us for a few minutes. No, that's okay. But here it has to come, There it has to come. Off ಯಾವ್ದದು? Can we do it probably from that itself? This system itself? It was coming, Lecture came very well. Kindly bear with us for a minute. Okay, anyway, by the time they adjust that, I will be telling about the satellite. The rocket which is being launched today, it is called LVM3. Okay, this is the heaviest rocket built by India. इधवरगो
रिटायरमेंट के बाद हर महीने लगभग 2.5 लाख की इनकम मिलेगी। क्या? कैसे? मुझे भी बता। सिंपल, स्मार्ट। अगर जल्दी रिटायर होने का सपना देख रहे हो,
can you restart it? What happened to that?
You know, when Steve Jobs introduced the first iPhone, he didn't show you a mobile with a list of features.
I told you about
At 5 minutes into the flight, the staging event takes place to separate the L-110 from the ongoing launch vehicle. The cryogenic stage C-25, which is the third stage of LVM-3, then ignites and continues to operate for 643.03,
that is its designation. The rocket which is launching it is
kilometers per second at the C-25 ignition increases to 9.7 kilometers. The launch vehicle climbs from 168 kilometers to 175 kilometers, that is 7 kilometers in altitude. The mission has been adapted to carry the heaviest satellite so far, CMS-03, weighing 4,410 kilograms into sub-GTO. The launch vehicle reorients to obtain the correct altitude after the cryogenic states shut down, and the satellite is injected into the orbit.
यहाँ काफ़ी अधिक संख्या में दर्शक दीर्घा भी उपस्थित इस प्रमोशन का आनंद लेने सभी छात्र छात्रा यहाँ उपस्थित हैं इनका उमंग देखते ही बनता है
it has actually, you can see this and see the way in which it is going. So you can see the rocket. Can you see that? Now it is better. You see that? Yeah. Oh, the two boosters have separated. Okay, exactly, that's good. Now the second stage is firing. The second stage is firing, and you can see, yeah, see, this is the way it has to go, and this is the way it is going. See, can you see that? Rocket launch is not child's play actually. See, it is, you imagine, it is as heavy as a 642-ton building. It is as high as a 14-story building, in fact, the rocket. Now it is, see how nicely it is firing. You know, liquid engines, two of them are firing, and yeah, now you know there is a protective heat shield which will be covering. Before a rocket and the satellite go to space, when it passes through the atmosphere, a heat shield is covering. Indian flag is there on that, you can see that. Once it clears the atmosphere, there is no need for that, it gets separated. Okay, so this is the way it is, and it is going up, and you can see lot of children clapping. And what happened? Okay, still they are showing. Yeah, you can see how it is being, you see, this is the satellite, this is the rocket, two engines are firing. Can you see that? Yeah, so you can see that, and so it has got three stages, let us say. First stage consists of two boosters. The second stage is the one which is firing, which uses liquid propellant. Propellant means fuel and oxidizer. See, they are firing. Okay, and yeah, still it is firing, you can see. See, now 286 seconds of flight is over. So the rocket is proceeding, going higher and higher, and now after the second stage's work is over, now you see it gets separated here, this point it goes back, and the third stage, which is a cryogenic stage, it takes over. Okay, so cryogenic stage. Okay, yeah, see, second stage also has separated. Third stage, now this is a cryogenic, look at that, this is the most difficult rocket technology, cryogenic stage. Say our chairman of ISRO, Dr. Narayanan, he is a specialist in that, cryogenics. Okay, cryogenic means, why it is difficult, do you know? For example, we use diesel or petrol in our cars and jeeps and all those, but in a cryogenic rocket engine, liquid hydrogen is used as fuel, liquid oxygen is used as the oxidizer. Both hydrogen and oxygen are liquids. I am breathing oxygen only. Okay, gas. Okay, hydrogen is also a gas. If you want to liquefy both of them artificially, to liquefy oxygen, you have to create a temperature of -183 degrees centigrade. How do you do that? If you think this itself is difficult, if you want to liquefy hydrogen, it is -253 degrees. See, in the rocket you have to put them in a thermos flask kind of thing, two different thermos flasks, and you have to feed them to the combustion chamber, pump them. Cryo pumps have to pump them into the combustion chamber. Here one is -253, one is -183. Once they mix, you cannot mix them just like that, they will explode. You have to, in a mist, okay, spray kind of thing you have to do. This is very difficult technology, and once you do that, you see how it is firing fantastically. This is a totally indigenous effort. Be proud of India, totally indigenous effort, this one. And when it fires, if there is on the way, when they are coming, when they are being pumped, if there is a problem, if there is a bubble, let us say, they will explode. The rocket engine explodes, that's all. It is called cavitation. That's what engineers say. Don't bother about such big things. So, all said and done, look at that, the way in which our cryogenic engine is firing inside. Why do we do all this circus? Because it is the most efficient rocket engine, cryogenic. Solid rocket engines, that is solid rocket engines burning solid propellants, they are like old Fiat cars. They fire, but they are not very efficient, or like a lorry, let us say, very old lorry. It has brute force, but not efficient. Solid propellants are somewhat like that. Liquid propellants are better. They are like Ambassador cars or even Maruti cars kind of thing. Okay, cryogenic rocket engines are the most efficient, a brand new car kind of thing. Very efficient one. Look at that, look at their faces, the way in which they are, this one. See, they have taken care of everything, checking, rechecking, all those things they have done. But still, look at the worried faces.
The Indian landmass to enable constant visibility of a satellite towards a particular region on Earth. The period of revolution of satellite in orbit should be same as the period of rotation of Earth on its own axis. This practically can be achieved if the satellite is placed at a slot at 36,000 kilometers above the equator. Launching a satellite into a geostationary orbit involves a meticulously planned series of steps. The LVM3 M5 rocket is expected to place CMS-03 satellite at an altitude of 180 kilometers with an inertial velocity of 10.15 kilometers per second. This orbit will have a perigee at 170 kilometers, which is the shortest distance of the satellite from Earth, and an apogee of 29,970 kilometers. That is the farthest it will be in the initial orbit, which is a temporarily stable orbit.
Okay, 950 seconds means 15 minutes.
The thrusters of the satellite are fired using the propellant carried on board at a precise point so that the apogee is at 36,600 kilometers. The next phase is the circularization of the orbit through a series of fine-tuned burns at apogee. That is how the satellite's velocity and trajectory are adjusted, and the satellite is placed at a precise slot in geostationary orbit. The designated orbital slot determines the launch window. Maintaining a satellite in geostationary orbit, ensuring its effectiveness and longevity, is quite a task in itself. Gravitational perturbations due to the celestial bodies and the space weather are common causes for the disturbance of satellite position from its slot. A process known as station keeping involves firing the thrusters to counteract these forces. Presently, the cryogenic stage is operational.
Otherwise, it's of no use.
And the performance is normal.
LVM3 भारतीय प्रमोचक यानों की श्रेणी में 5वीं पीढ़ी का प्रमोचक यान है, जिसकी क्षमता 8000 किलोग्राम उपग्रह को निम्न भू कक्षा में ले जाने की है। LVM3 के पिछले मिशन LVM3 M4 में भारत के गौरवशाली चंद्रयान 3 का प्रक्षेपण 14 जुलाई 2023 को दक्षिणी दिशा का है, जिसके माध्यम से भारत चंद्रमा के दक्षिणी ध्रुव के पास सफलतापूर्वक उतरने वाला पहला देश बन चुका है। ग्राउंड स्टेशन हम 2023 में ही LVM3 M3 और M2 ने OneWeb के कुल 36 उपग्रहों को प्रमोचित कर एक कीर्तिमान हासिल वाला पहला देश बन चुका है। 2023 में ही LVM3 M3 और M2 ने 5वीं प्रचालन के कुल 36 जून 2017 से शुरू करते हुए 2 विकासशील उड़ानें हासिल किया और उसके पश्चात LVM3 रॉकेट को पूर्णतः प्रचालित कर इसमें
यह
चार
LVM3
प्रसिद्ध
की पांचवीं
प्रमोचन हो
प्रचालन
चुके हैं
उड़ान है,
जिसमें चंद्रयान 2
जून
2017 से शुरू करते
के
हुए
दो
दो विकासशील
और
उड़ानें हुई
चंद्रयान
और उसके
3
पश्चात
शामिल है।
LVM3
इस
रॉकेट
कड़ी
को आगे
पूर्णतः
बढ़ाते हुए
ನೋಡಿ ಇವಾಗ ರಾಕೆಟ್ ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ತೀನಿ. ರಾಕೆಟ್ ಇವಾಗ ಸಾಕಷ್ಟು 16 ನಿಮಿಷ ಹೋಗ್ಬೇಕದು. 16 ನಿಮಿಷ ಕಾರ್ಯನಿರ್ವಹಿಸಿದ್ರೆ ಅದು ಈ ಉಪಗ್ರಹವನ್ನು ಬೇಕಾದ ಕಕ್ಷೆಗೆ ತಗೊಂಡೋಗುತ್ತೆ. ನೋಡಿ, ಆದರೆ ಇನ್ನೂ ಅದು ಹೋಗ್ತಾ ಇದೆ. ಇವಾಗ ಅದರ 3ನೇ ಹಂತ ಅಂದರೆ ಕ್ರಯೋಜೆನಿಕ್ ಹಂತ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂದರೆ ನೋಡಿ, ಇವರೇ ರಾಕೆಟ್ನ ಬಿಲ್ಡ್ ಮಾಡಿರೋಂಥ ಇಂಜಿನಿಯರ್ಸ್. ನೋಡಿ ಎಲ್ಲ ಎಷ್ಟು ಹೆಂಗಾಗಿದ್ದಾರೆ, ಎಷ್ಟೊಂದು ಜನ ನೋಡಿ. They're all very young people who have built this rocket. They are the ones who have built it. Oh, so look at that. See, this is the way thrusting. We call it as thrusting. So it is firing. Okay. Look at that. How many of them are there? Okay. ISRO chairman is there. Look at that, the way in which it is going. See, C25 off means the rocket engine stops at that time. See, the rocket, the brain of the rocket will be calculating what is my speed. At this time, what should have been my speed and what is the difference between the two. In order to minimize this difference, what should I do? These are the things. It will be microprocessor based brain is there in the rocket. It will be doing that, that black color thing below the satellite is there, that is where the brain of the rocket will be residing. In fact, look at that. ನೋಡಿ ಇವಾಗ ಎಷ್ಟು ನಿಮಿಷ ಆಗಿದೆ. ಆಲ್ಟಿಟ್ಯೂಡ್ 170 ಕಿಲೋಮೀಟರ್ಸ್, ವೆಲಾಸಿಟಿ 7.6 kilometers per second means per hour it is traveling at 26,000 kilometers per hour. Can you believe? 10 minutes back it was standing like a rock. Now it is. Look at that, how students are this one they are clapping, and this is what is modern India you should be proud of, especially younger students. Please get inspired by this, what India has done. You should do better. Yeah, she is showing her hand. Very nice. Give her a big hand. Really good. Look at that, how it is going. Look at that, how precisely it is going. See, that red line or the blue line there on the top is the ideal one. The one which is above that green colored line is the actual one. The actual one is almost hugging the ideal line. So that shows how efficient you are. See, look at that. Time is 8:86 seconds. Another 2 minutes. That's all. Okay. Now let us see what happens. Now the rocket is moving very fast, very fast. But you see, it is not only firing of the rocket engine which is important. Your direction maintenance has to be proper. Otherwise, if you turn this way, that way, gone. So look at that. These are the people who have built the rocket. Say, relative velocity is 9 kilometers almost. Okay. Look at that. We have come very near. Okay. Very near. Very near to that. Another 30 seconds, that's all. Another 30 seconds and the rocket engine stops. Okay, you can see the animation. Another 30 seconds, that's all. It's already at 170 kilometers. The velocity is more than 30,000 kilometers per hour. 30,000 kilometers per hour in 15 minutes. Okay, 9.4. Look at that, 9:49. Another 10 seconds or so, that's all. Yes, I think almost it is over. Okay. Yeah, it has to stop at 15 minutes. It's not that its brain knows. Brain will be there, somewhere there, down below. Okay. So if you see what is the time at which it has to stop, it knows very well. Okay. Yeah, see. Oh, good. It has done its job. Let us see. The satellite has to separate. Now you see the satellite, how it separates from the rocket. It is moving at only 33 to 34,000 kilometers per hour. That's relative to us. Okay. Now the rocket has to separate the satellite. It takes a few seconds for that. See, these are the people who have built the rocket. Okay. Look at there in the last row, a lot of lady engineers are there. Can you see that? See, they have also worked very well along with others. Okay. GMT. Okay. CMS-03. Let us see what is the latest thing. Let's wait. Can you check in mobile? There is a difference between this and directly coming.
Mission accomplished. LVM3 M5 CMS-03 mission accomplished. Handing over to mission director. Mission director 3 M5 launch vehicle has injected. LVM3 M5 launch vehicle has injected orbit. CMS-03 mission has been successfully accomplished. Orbit. Mission has been successfully accomplished.
This is the heaviest rocket which India has built. LVM3.
जी हाँ, अभी आपने सुना ये हर्षोल्लास का पल, जी हाँ, अभी आपने सुना ये हर्षोल्लास का पल जब LVM3 M5 CMS-03 सफल को रहा है, CMS-03 उपग्रह को स्थापित कर दिया गया है, उद्दिष्ट कक्षा में स्थापित कर दिया गया है.
In the mission control center, concentration here in the mission control center. Up next, on the success is the address by Chairman ISRO. Up next, the address by Chairman ISRO.
That's what I said.
Dr. V. Narayanan.
Yeah. Anyway, all I can say is the satellite will play a very important role in the comprehensive security of our country. That's all I will say. Okay. A lot of people there who are all there. See, today comprehensive security, food security, economic security is important. Apart from security means military security, not only military security, economic security, social security. All these things are very important. You can see ISRO chairman actually congratulating all of them, all the people there. Now you can see people congratulating each other, and let us say what he says. At 974 seconds, it has separated. Okay. Hardly 960 seconds, 16 minutes the rocket has taken to launch the satellite in proper orbit. Now the satellite is following an orbit which is highly egg-shaped. Okay, when it is very near to Earth, it is about 170 kilometers or something. When it is very far away, it is around 30,000 kilometers. That is the height. That is the size of the orbit. You can see the young engineers being congratulated by Chairman ISRO, and we have every reason to celebrate as Indians. And let me tell you, the same rocket LVM3, which is further, whose let us say reliability is much more enhanced, that version of LVM3 today, whatever launch you saw, that is the one which is going to launch Gaganyaan spacecraft, our astronauts in fact. That is the one. Same rocket. It can put 8 tons into a 400 kilometer orbit in fact. And this is only 4.4 tons because it has gone into a very high orbit. That is the reason. And you can see. Can you give the yeah, I can present to him. I will interpret it.
Good evening to all of you. I am happy to announce that all of you LVM3 M5 launch vehicle has successfully LVM3 M5 launch vehicle has successfully communication satellite injected the CMS-03 communication satellite in the required orbit. Satellite weighing 4,410 kg. The satellite weighing is 4,410 kg is injected precisely within the specification of the orbit. Injected. Let me congratulate within the specification of the orbit. Entire ISRO community. Let me congratulate the project team. The entire ISRO community.
Yeah, you can give there.
Industrial partners, all the team members, your outstanding industrial partners for accomplishment of this great mission. Your outstanding contribution. This is our 103rd launch from Sri Harikota. This is our 103rd launch from Sri Harikota. 8th successful mission of the LVM3 successful mission of the LVM3 launch vehicle. As all of you are aware, LVM3 vehicle aware that is the previous LVM3 vehicle launched the LVM3 M5 prestigious Chandrayaan-3 mission. Most prestigious Chandrayaan-3 mission. Glory to the India brought as the glory to the India as the first country spacecraft land successfully near the spacecraft of the moon. Successfully near the south pole of the moon has brought yet another important glory to India. Yet another important glory to India is the heaviest CMS-03 is the heaviest satellite launched by the LVM3 to the GTO orbit so far. For accomplishing this, the vehicle has to be improved, the performance has to be improved in multiple directions for enhancing the payload capability by 10%. In today's mission, all the vehicles systems have performed satisfactorily and the orbit we have achieved within the required specification. I am also happy to announce that till today we have done 8 LVM3 launches, including the first experimental mission. And all the launches so far accomplished by the LVM3 vehicle is 100% successful. This great success is due to the open work culture of ISRO, meticulous and systematic mechanisms put in place for the review of various activities, and the dedicated, hard and smart work of Team ISRO along with our industrial partners. Let me take this opportunity to congratulate each and every one of you, our family members, our industrial partners and the academia who have wholeheartedly support for this mission. Coming to the satellite, the CMS-03 satellite is a multi-band communication satellite with coverage over a wide oceanic region, including the Indian landmass, and is designed for providing communication services for at least 15 years. The satellite incorporates a host of new technologies and yet another shining example of Atmanirbhar Bharat. Let me congratulate the entire satellite team spread across various ISRO centers for realizing this very, very important, improved, complex satellite for the communication capability of our country. I must tell that we had really a tough, challenging time during the launch campaign. You know, the weather was not that cooperative. But then, let me take this opportunity to compliment each and every one of you. Even under this difficult weather condition, we could come out successfully and accomplish this mission in a grand manner and successful manner. Dear friends, let me also congratulate all the review team members, chairmen and members of various committees, including our mentors and earlier leaders who have shoulder to shoulder with us for accomplishment of this mission. We really congratulate and compliment each and every one of you and our family members on this occasion. And I also would like to announce an important experiment what we have carried out. The indigenously developed C-25 cryogenic stage. For the first time, we have, after successfully injecting the satellite in the orbit and reorienting the stage, for the first time, we have successfully ignited the thrust chamber. For the first time, reignited the thrust chamber. And this is going to be a great experiment which is going to feed data for restarting the cryogenic stage in future, for enabling the mission flexibility for placing multiple satellites in various orbits using the Bahubali rocket LVM3. Once again, my heartiest congratulations to each and every one of you. Now, along with me, we have got the project directors of the both launch vehicle and satellite, and all the center directors who have worked hard for accomplishment of this mission. Let us hear first from the LVM3 project director, Mr. Victor Joseph. Mr. Victor Joseph.
Good evening, ISRO. Good evening, India. LVM3 has done it once again. Most respected Chairman ISRO, former Chairman Kiran Kumar sir, center directors, senior members and dignitaries here, and all those present here and online. Congratulations to each one of us for the 8th successful mission of LVM3. And this time, the vehicle has lifted the heaviest communication satellite from the Indian soil, the CMS-03, and injected it into the required orbit. And also for the first time, we have demonstrated the reignition of the cryogenic engine.
5 minutes, I will
on
show
this
you
proud
how big
occasion,
the rocket was. You can stop the audio. You can see. This is what I thought I would show you before this one. Another 5 minutes only. You can see how big the rocket was. Next one quickly. Alle madi parayilla. Look at that. This is the way the rocket stood 20 minutes back. This is the way it is. 15-story high rocket. This is Sriharikota, 80 kilometers north of Chennai. Okay, in the district of Nellore in Andhra Pradesh. Next one quickly. So this is the rocket, Bahubali rocket, which ISRO chairman himself said. This is the Bahubali rocket, which is 15 stories high. Okay, next one. Yeah, this is the liquid stage, which is in the central part of the rocket. 2 engines are there on its back. Next one. Next one. Yeah, you see, this liquid stage is attached to 2 solid stages. 2 solid stages. Next one. Yeah, this is the cryogenic stage, I told you. Now, what ISRO chairman was telling is, after the satellite was injected, the satellite went away. When it is nearby, no experiment should be done. Something may go wrong means it is a problem. So the satellite sped away once they pushed it from the rocket. Then what they have done is, they have reignited the cryogenic engine again. This engine they have reignited. So what you may say, I will stop my car and again I will push the ignition key, and it is not like that for rocket engine. No, there is no guarantee like that. So a restartable cryogenic stage is still horrible. It is not easy. And we have done that today. We are proud to be Indians, in fact. Next one. Okay, and previous one you go. Previous. See, this I told you, this is a fully indigenous effort. This is a great example for Atmanirbharata, what we say. Because earlier we had a different kind of rocket engine technology which we tried to obtain from Russia. Not just like that, buying some masala dosa kind of thing, not that kind of thing. But partially we thought we would procure from Russia, and at the same time we would do something. Then somebody else came in between and there was difficulty, all these things. I don't want to go into that. So in that process, ultimately somebody else's technology to perfect it, it was not easy. We took a long time, but we tried there. Ultimately, in 2014, we launched that kind of thing. 2 years later, we launched this cryogenic stage in LVM3. Nobody has helped for this. This is a totally indigenous effort. This is a different kind of cryogenic technique. Next one. Next one. Okay. See, look at that. This is the cryogenic stage which is placed on top of the liquid stage, second stage. These two are the solid stages. Next. Look at that. This is the part. This is the heat shield. This is what separated once it went out of the Earth's atmosphere. So, what happened? Okay, it has come back. Oh, I think this is a cable problem, I am sure about it. Okay, leave it. See, this is the heat shield. This has to protect the satellite when we are in the atmosphere. Otherwise, satellite gets damaged. You have to, you see, it is like a cigarette butt kind of thing. So, the air which comes down has to flow around it without any problem when you are in the atmosphere. So, look at that. This itself is so big. This is the dimension of a man. Compared to that, look at that. This itself is so big. 4-story high. Next. See how they are lifting it using cranes. It has come separately, and now they are going to place it on top of the rocket. The satellite as well as the brain. It contains that. Next. Why? Okay. What happened? Another 2 minutes only. I want to show you the. Okay, if it doesn't stream, it don't bother. If it goes, this also goes. It is a big problem now. Now let us have a thorough checkup of our system, and we'll have redundancies where you go up, still go up. Why down? Go up. Still. Yeah, the 10. Yeah. Look at that. So they are lifting it using cranes. Next. See, they have placed it on top of the second stage, the third stage, cryogenic stage. So this is the satellite and the brain of the rocket. They are integrated. Next. Okay. Look at that. The entire vehicle with the satellite is being taken on a rail track to the second launch pad at Sriharikota. Next, look at that. This is the thing. See, when the vehicle lifted off, these two were the ones which were firing. Okay, each one of them contained 2,04,000 kilograms of propellant, 2,04,000 kilograms of propellant. So 4,08,000 kilograms of propellant is there, and those are being used, and the rocket lifted off today. Unfortunately, we could not see it in the big screen. Okay, but the propellants inside that 2,04,000 here, 2,04,000 here, they were washed out, solid propellants. They were sitting like concrete blocks. They were washed out within 2 minutes 20 seconds. 4,08,000 kilograms of propellant washed out in 2 minutes 20 seconds means what is the prodigal rate at which the propellants got consumed by these two rockets. That is why if this entire rocket is Bahubali, I have named these two as Bakasurs. Okay, that is the way they consume the propellant, because 4,08,000 kilograms of propellant, if it is washed out in 2 minutes 20 seconds, what is the prodigal rate at which it is eating? Proverbial Bakasura, in Mahabharata he comes. He used to eat at a fantastic rate, not only whatever was brought, and the person who brought also was devoured by him. So they make me to remember that. Quickly, next one. See, this is at the launch pad. There are two launch pads in Sriharikota. This is the second launch pad. Okay, look at that, and fantastic. If you go near the launch pad and see, you will realize what India is, what Atmanirbharta is. Everything, nobody has helped, everything is Indian. Everything is Indian. So be proud of it. Next. See, can you space bar kodi? This is a drone picture. Now you see how it looks in a drone. See the way in which it is there. So it is going out, it is zooming out. See, this is the thing, and you can see the rocket. Now anyway, the launch pad has to be refurbished because the rocket is lifted off, has lifted off already. Okay. So the heaviest satellite to be launched from the Indian soil today, 4,410 kilograms. Okay, Bahubali. Okay, this is the thing. See the beautiful video. So this is the way it is, and at Sriharikota, this is one of the greatest places. You know, we have a lot of advantage. If you launch a satellite from Sriharikota, you have a lot of advantages compared to other launch pads. Even Kennedy Space Center from the United States, compared to that, this is better. Next one, quickly. See, we started with our communication satellite called Apple in 1981. In those days, facilities were not, they were rudimentary or very limited. Look at that. This is not a joke. This satellite was taken out in Pune to perform a test on a bullock cart. This is not joke. This was really required at that time. This was sometime in 77, 78, 50 years back. Today, we have a building. You take all the ingredients, like making upma, you have semolina, rava, you require water, you require something else, and you require coriander, you require chilies, all those things. You have salt, take inside. So like that, you take all the ingredients of a satellite. You can build the satellite, you can test them extensively, take out, and you can take it to launch pad directly. That is the facility we have near Marathahalli. So this is, not many countries have, only a very few have. Next, this is Atmanirbharta. This is yet another communication satellite called GSAT-11. You know what is the weight of this satellite? It is 5,800 kilograms. Today's satellite is 4,400. This is the largest and heaviest communication satellite built. Aryabhatta, inside the planetarium, you can see it could generate only 47 watts of power. 47. Only 40 watts bulb kind of thing. This satellite can generate an electrical power of 14 kilowatts. Where we have come. See, this is the way. Next. So today, whether it is for ATMs, whether it is for stock exchange, whether it is for high-speed internet data, whether it is for e-governance, whether it is for railway and aeroplane ticket booking, you require satellite. You go to any ATM and see on top of, there is an antenna like that will directly communicate with our. Look at that. This is the, today 50 satellites are working for India at this moment of time. This has joined now, whatever, today CMS-03. Next, look at that. Ultimately, CMS-03, the satellite which was launched today, has to reach geostationary orbit 36,000 kilometers high. Now the rocket has taken, LVM3 has taken it into an intermediate orbit. From here, it will be taken to its ultimate orbital home, geostationary orbital home. Next. That's it. Thank you. Thank you very much. Sorry about not being able to see the launch. Despite our efforts, we don't know. From next time onwards,
when he's taking his journey towards the final intended orbit. And also we have the, to increase the payload capability of from the cryogenic stage, the thrust was also increased by around 0.3 tons, which also gave additional payload improvement to meet this requirement of higher mass as well as the orbital requirements. And finally, when we have the cryogenic ignition initially and the entire 700 plus seconds was functioning completed to come to the satellite injection, it was cryogenic stage was shut down and the satellite was injected. But as an experiment, we have reignited the engine in a very difficult ignition conditions of a hard vacuum, and that was also successfully demonstrated by the change in acceleration, and that is a great experiment which is going to give us a lot of confidence in the future to proceed with flexible mission programs. So all in all, the L110 stage and the cryogenic stage as well as satellite propulsion system all have functioned very nicely, and the satellite propulsion team has a further long way to go. I'm sure we are going to have a very successful journey beyond this stage and to the final orbit. So congratulations to specifically to the LPSC team, also the integration team at IPRC and the IPRC entire combined team of both the centers. And I'm sure we will have many more successes within the next few months itself. Thank you. Congratulations again. Jai Hind.
Good evening to all. Congratulations to the entire nation. It has been very challenging to make the liquid stages, the testing of the liquid engines of L110 stage and the cryogenic stage, the integration of the